Hello and good day I bid to everyone who's watching this video. Welcome to our presentation about our project proposal for the subject KIB3005 Biomedical Engineering Practice. And I'm from Group 5, and together with me in this presentation, there will be my team members, starting with Ooi Hui Luan, who's the leader of this group, followed by Audrey Richard, Nur Ezleen, Hui Yee, and myself, Vissagan. Moving further into the slides, now I'd like to address a severe clinical issue that we have identified based on our visits to the University Malaya Medical Center, or UMMC. As we know, many medical devices are sterilized and wrapped in a vacuum packaging. This is because to ensure and prevent any sort of contamination to the medical devices itself. Pharmaceutical packaging can lead to large production of medical waste, which has been an alarming issue in the current era. With the global pharmaceutical packaging market tipped to grow by 6.1% annually to the year 2027, according to the Allied Market Research, its impact will only increase without significant commitment to improving sustainability. An estimated 25% of hospital waste is actually plastic, according to the researchers from the University of Ulsan and also the University of Massachusetts Lowell. And you might wonder, what happens if a pharmaceutical packaging has a low tensile strength? Well, if the pharmaceutical packaging has a low tensile strength, it has the higher tendency of tearing or puncturing. Material tears in a clinical setting can actually cause contamination of bacteria from the surrounding itself. Contamination can cause serious infection among patients, especially in a clinical setting, which are the operation theatre and also the intensive care unit or ICU. So our solution to these clinical issues is that we expect to do testing of tensile strength of different packaging films and also Tyvek materials. And we also have to identify the best combination of materials to best fit in a clinical setting and also sustainable in the long run. By doing this so, we are actually lowering the chances of steel tearing or puncturing, which may cause contamination. And by conducting a series of experiments to investigate the material properties based on certain parameters, we are able to identify the best combination of packaging film and Tyvek material to address this clinical issue or to solve this clinical issue. In the next part of the slides, I would like to address three hypotheses that we have identified based on our three experiments that we are planning to conduct as a group. The first hypothesis, which focuses on the temperature parameter, saying that different materials have their own optimal sealing temperature to obtain the highest tensile strength. In the next hypothesis, or the second hypothesis, focuses on the second parameter, which compares the different packaging film with the EP1250 film. And among the M' BOPP and MDOPE films, BOPP packaging film performance is much closer to the EP1250 film and has a higher heat resistance. In the final hypothesis, which focuses on the different Tyvek combination, and among the combination of BOPP packaging film with the 2FS SPP2000, 1059B SPP2000, and 1073B SPP2000 Tyvek material, the 1073B SPP2000 Tyvek material has a higher seal strength with BOPP compared to the other Tyvek materials. And now I would like to pass the baton to the next presenter to explain further into the presentation. Thank you.
Hi, I'm Hui Luan and continue explain on the design of the prototype. A medical pouch is used to package single-use disposable medical devices or surgical instruments which require a high level of sterility. The pouch is created by bringing two webs of materials together and sealing them on three sides, leaving the fourth side open. The product is then inserted into the pouch and then is heat sealed across the final side to create a sealed package in preparation for the sterilization process. It involves a firm materials and a Tyvek. The firm materials is the plastic-like parts, while the Tyvek is the paper-like parts. Tyvek and films is the most common material combinations used for medical pouches. Heat-sealed packaging machines have heating elements that are heated to a degree that either melts or activates the sealant. The temperature must be high enough to activate the sealant layer without scorching the material surface. In the three experiments we planned, the materials used for the film are EP1250, M', BOPP, and MDOPE, while the materials used for the Tyvek are 2FS SPP2000, 1059B SPP2000, as well as 1073B SPP2000. Since we are testing on which materials has the closest performance as EP1250, but having greater sustainability, we still need to consider the benefits of each materials. From the table, we can see that EP1250 is having high seal strength and durability with high heat resistance. However, it is not recyclable. M' is the material made of PE under MCO flexible Malaysia. It reduces the non-renewable energy dependency by 60% and reduces carbon footprint by 46%. It has high stiffness and tensile strength with high film clarity and product visibility. Recyclable and sustainable in the long run. While for MDO-PE film, it can achieve maximum performance with a minimal thickness. The shipping cost will be lower with less PE materials. It has high pressure resistance, great printability, great stiffness, as well as good tear and shock resistance. Lastly, for BOPP film, it offers a superior moisture barrier, while the metallized version improves the product's oxygen barrier. It has a wide sealing window, a low seal initiation temperature, good machine ability, and good heat seal strength. BOPP film has a relatively low carbon footprint. It has low density and can increase the yield during conversion. Next, we move on to the benefits of the tie web materials. For 2FS, it is light and thin, while for 1059B, it has moderate weight and thickness, while 1073B is the thickest and heaviest. 2FS is able to withstand the significant temperature. 3 of the tie web materials have resistance to microbial penetration, as well as high depth strength and puncture resistance, so that it can make sure that the medical equipment is safe during the shipping process. 1073B has higher tensile strength. 1059B and 1073B has longer shelf life. We need to carry out experiments to choose which is the best medical packagings among the Tyvek and firm's sealing combinations.
Hi, I'm Audrey. So for experiment 1, it will be on the effect of sealing temperature on the seal strength of medical packaging pouch. So as we all know, each material will have different tensile strength which it varies at each temperature. So in this experiment, we will fix the pairing material which is the EP1250 as the top material and the 2FS Tyvek as the bottom material, while the parameter will be the sealing temperature. So first we will determine the sealant with the testing marker and attach it to a stapler. So make sure it was facing inwards and label the measurement direction so that it can be sealed properly later on. Next, we will seal it starting from 120 degrees Celsius with sealing temperature controller. The pressure will be fixed at 72.5 Pascal and sealing period was 2 seconds. So after that, we will cut the sealed sample into 3 strips of 1 inch. Then the strip will be put into the tensile test machine for tensile testing, and the average tensile strength will be calculated. Then we repeat the procedure by repeating 5 degrees Celsius from 120 degrees Celsius to 140 degrees Celsius. The temperature below 120 degrees Celsius is not used because from what we have researched, it can't be sealed properly as it can't activate the formation of the bond. So as for the expected outcome, up until a certain temperature, the tensile strength will start to decrease. This is because the extreme high sealing temperature will cause deformation of EP1250. So based on the orange curve that we have seen on the graph, the tensile strength machine and the tensile strength increase up until a certain temperature and it starts to decrease later on. So therefore, the optimum temperature for the EP1250 is expected within the range of 120 degrees Celsius to 140 degrees Celsius. So that's all for my part. Thank you.
Hi, my name is Hui Yee, and I will proceed with experiment 2, which is the comparison between the recyclable film materials MDO-PE, BOPP, and M-Prima with the non-recyclable EP1250 film on their tensile strength. The objective of this experiment is to compare the performance of MDO-PE, BOPP, and M-Prima film in terms of their tensile strength and heat resistance using EP1250 as control. So as mentioned in the previous part, EP1250 is a polyester film that commonly used in medical device packaging due to its high tensile strength, transparency, and durability. However, this material film is non-recyclable, and the drive nowadays is toward achieving sustainable packaging goal and slowly eliminate non-recyclable packaging. Hence, the recyclable films is of our interest. So MDO-PE, M-Prima, and BOPP are the recyclable films that are going to be tested in this experiment in order to find out the one that will best replace EP1250 with excellent seal strength and heat resistance. In this experiment, we are going to create a medical packaging pouch which consists of a top material and a bottom material. The top material is altered between EP1250, MDO-PE, BOPP, and M-Prima, whereas the bottom material is fixed with Tyvek 2FS SBP2000. Each combination will be sealed at different temperature to compare their differences. For EP1250, the sealing temperature is ranging from 120 to 140 degrees Celsius. This is because EP1250 has very high heat resistance, where it can be sealed up to 190 degrees Celsius. While for MDO-PE, BOPP, and M-Prima, the sealing temperature range is 100 to 130. This is because the recyclable materials tend to have lower heat resistance and they cannot withstand too high temperature. For the methodology part, the first step is attachment of materials. There will be 4 combinations of materials. which are EP1250 paired with 2FSSBP2000, and then the EP1250 will be replaced by another top materials which are M', BOPP, and MDOPE. So the sealant part of each material will be determined, and for better sealing purpose, each combination of materials is stapled at one side with the sealant part face inward, and we need to make sure that the orientation of machinery direction is correct. So there will be a total of 7 samples prepared for each combination of recyclable materials, while for the EP1250, there will be 5 samples prepared to be sealed at different temperature. Next, for the sealing process, the sealing temperature controllers are adjusted to the desired temperature for each pad samples, and the sealing pressure is fixed at 72.5 Pascal. Then, after the sealing process, the sealed samples are cut into 3 strips for 1 inch length by using the 1 inch cutter. Lastly, each strip is then placed into a tensile test machine for tensile strength test, and the average of reading is examined. So for the expected outcome, we expect that EP1250, which acts as the control in this experiment, will obtain the highest seal strength and yield consistent result. Among the 3 recyclable materials, BOPP film is expected to obtain the highest tensile strength and with greatest heat resistance with wide seal window, which means that the BOPP film can be sealed at wide range of temperature and not melting even when the temperature is become higher. Lastly, BOPP film is expected to be chosen as the best material that can replace EP1250 due to its recyclable properties and also excellent sealing performance. So that's all for experiment 2. Now I will pass to Ezleen to continue with experiment 3. Thank you.
Hello everyone, my name is Ezleen and I will continue with experiment 3, which is the effect of different combination of materials on the tensile strength. The pairing materials used in this experiment are BOPP with 2FS SPP2000, BOPP with 1059B SPP2000, and BOPP with 1073B SPP2000. BOPP is an acronym for biaxially oriented polypropylene. Next, about the experiment. For the introduction, the purpose of this experiment is to study which pairing materials that will have good sealing strength for medical pouch use. The manipulated variables is the bottom material used for combination in pairing materials, the Tyvek, because different Tyvek will have different thickness and we're going to fix the sealing temperature to 130 degrees Celsius and the top material which is BOPP film. Next, for the methodology, first, a sample for each pairing material is created by stapling both materials together and ensure that the sealant part is facing each other. Plus, make sure that the machinery direction and the types of combination is labeled on the sample. Next, the sample are sealed with a temperature of 130 degrees Celsius within 2 seconds and pressure of 72.5 pounds per square inch (psi). Then, the samples are cut into 3 strips for 1 inch width using 1 inch of sample cutter. Lastly, each of the strips are tested by tensile test machine and special software to get the average reading. So, for the expected outcome, the comparison between different pairing materials should be done to choose the best combination of bottom pairing materials with BOPP. We expected that combination of BOPP with 1073B SPP2000 will have the highest tensile strength since it has the thickest film, best puncture resistance, and the durability is high. In summary, ideally all materials have its own characteristic. Hence, to avoid contamination in medical devices, good sealing properties or tensile strength should be determined to ensure no harm to patients. For experiment 1, the tensile strength of EP1250 increases with the sealing temperature until an optimum point and starts to drop. But the temperature must be high enough to activate the sealant layer without scorching the material's surface or causing it to become excessively transparent. For experiment 2, among all of the recyclable film, BOPP is expected to have the highest seal strength and good heat resistance. Consequently, it is the best material to be replaced with EP1250, which is non-recyclable film based on our research studies. For experiment 3, BOPP and coated Tyvek 1073B SPP2000 has the greatest tensile strength, as the Tyvek 1073B SPP2000 is the thickest and the heaviest. Therefore, it will also offers the highest tensile strength, best puncture resistance, and the durability is high, suitable to be used to sharp medical device packaging. That's all from us. Thank you.